Hey guys, so today we're going to still focus on distance and time graphs. We know that our distance is represented on the y-axis and that our time is represented on the x-axis. So we're going to look at this graph, which represents go-karts, and answer the questions together. So number one says, when did the go-kart stop? So when was the go-kart stationary or not moving? So we know that a horizontal straight line, represents an object not moving. So we can see that within our graph, from this point to this point is when the go-kart was not moving. So it is asking for the time. Times, because if you also look at the very end of our graph, from this point to this point, the go-kart was also not moving. So from this point, which is at 14 seconds, so from 14 seconds to 18 seconds, the go-kart was not moving. And from 34 seconds to 38 seconds, the go-kart was also not moving. So let's go ahead and erase my little drawings. So in number two, it says, at what time did the go-kart begin to slow down? So when we have curved lines, so if I have a line that is like this, it has a little dip in it, that means it's de-accelerating. So that means it's slowing down. When it's like this, that means it's speeding up or accelerating. So we're looking for a little dip within our graph. And we can see that dip over here on the right-hand side. Here we have steady, 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 stopped, steady, steady, steady. And then right about here is when that dip happens. So we got to look and see where that dip happened. So it's right here, and then that dip occurs. And I'm going to erase my mark so you can see that. So you can see right here is the beginning of that dip. So what time stamp is that? Well, if we trace back down to our seconds, that is at 26 seconds is when it starts to slow down or deaccelerate. So number three says, at what two times is the go-kart traveling at a steady speed? So we know that steady speed is represented by a straight line that is at an angle. So a steady speed is something like this or something like this. Those are steady speeds. They're straight lines at an angle. So we can see that from 0 to 14 seconds, that this is a steady speed. This speed is steady. So what two times did the go-kart traveling at a steady speed? So our first was at 0 to 14 seconds. 0 seconds to 14 seconds. And then our other steady speed starts at 18 seconds. And steady, steady, steady. But then right here, you can see that it's not steady anymore because it's not lined up perfectly with these little graph lines. So from right here is when it stops being steady and starts to de-accelerate. So from 18 seconds to 26 seconds is when it's traveling at a steady speed. All right. Number 4 says, what was the total time of the go-kart trip? So what was the total time? So our total time we have 0 seconds, and it stops at 38 seconds. So our total time is 0 to 38 seconds, which is 38 seconds. Number 5 says, what was the total distance the go-kart traveled? So this is where it gets a little bit more tricky. So we know that our distance is starting at 0. It's going. The highest it gets is right here at 35. Then it stops, and then it goes back down, or not goes back down, it turns around. It goes back towards the starting point. It stops right about here. So this distance, it didn't go all the way back to the starting point. It's 5 feet shorter than the starting point. So we have 35, 0 to 35, and then 35 to 5. So 35 minus 5 is 30. So it travels 35 meters and then 30 meters. So all we need to do is add those up, which would give us 65 meters. That's the total distance it's traveled. So number 6 says, what was the average speed of the go-kart for this trip? So we already have the distance and we already have the total time. So to find the speed, we need the total distance and the total time to find the average speed. So our total distance was 65. So to find speed, we need to do 65 divided by 38. And so this is actually going to give us a decimal because this will not go in fully. So I just want you guys to try your best and remember long division. So 38 is going to go outside my box as my divisor, and 65 is going to go within my box. So 38 goes into 6 0 times. Move over. 38 goes into 65 how many times? So I'm going to multiply 38 times 2 to see. 2 times 8 is 16. 2 times 3 is 6. Okay, so 38 twice goes over. So it can't go twice, so that means it only goes once. 1 times 38 is 38. Subtract. 5 minus 8 can't do that. Borrow. That becomes a 5, and this becomes a 15. 15 minus 8 is 7, and then 5 minus 3 is 2. So I have a remainder here. And so I really want this to have a decimal in it to calculate time. So all you need to do is add a decimal at the end and bring it up, and then add a 0 like we do when we divide decimals so we don't get a remainder, and bring that 0 down. 38 goes into 270 how many times? So we're going to guess and check. Oh my gosh, what just happened? Okay, 38 times, let's do 5. I'm just guessing here, guessing and checking. 190. So we can go in more than 5 times. Let's try 7. $266. So if I did another 30, I would definitely go over 270. So it can go in 7 times. 7 times 38 is 266. Subtract and get 4. So after you get one digit after your decimal, you can stop there and just put 1.7 as your answer. You don't need to keep adding zeros and bringing them down. You can if you want to get a more accurate answer, but I will count 1.7 as correct on your worksheets this week. So just add the decimal, add a 0, bring it down, and repeat 1 time. Okay? All right, so our final speed was 1.7 meters per second. All right, I'm going to clear this. And number 7 says, which of the following statements is true according to this graph? Let me zoom out so we can see the graph. So A says the go-kart was at rest from 0 to 14 seconds. No, that's not the case, because from 0 to 14 seconds, it had gone 35 meters in 14 seconds. So it was definitely moving. So that one's definitely not the correct answer. B says the go-kart was traveling at a steady speed from 0 to 14 seconds. Yes, that would be our correct answer because remember, a straight diagonal line means steady speed. So B would be our answer. C and D says, C says positively accelerating. That means we would have dips. So this would be positively accelerating, negatively accelerating. So we would have dips, and we don't from 0 to 14 seconds. All right, so your work this week is going to look a lot like these graphs. Remember, when you're calculating the average speed and you get a remainder, just add a decimal to the end, bring it up, add a 0, and bring that 0 down, and repeat one time. You don't need to keep repeating because it might just keep repeating forever, and that would not be fun for you. So let me know if you have any questions, and thank you.